Hello everybody, we're looking at problem 19 from the 2022 AMC 10A. I really like this problem because I think it embodies both the spirit of the math challenges and the math Olympiads, which is looking for really powerful shortcuts. And I think it also embodies the spirit of mathematics, which in many ways is the art of the shortcut. But not only that, I'm also going to teach you a really important lesson about remainders, about how to quickly calculate them. So we're actually going to start off with this, with the problem. And then if you want to see why the remainder trick works, you can hang on until the end of the video and I'll explain it in a bit more detail. But let's look at the problem first. So define Ln as the least common multiple of all of the integers from 1 to n inclusive. There is a unique integer h such that the sum of all the reciprocals equals h over L17. What is the remainder when h is divided by 17? Okay, so the first thing we need to do is actually work out what 17 is. So 17 needs to be a multiple of all the numbers from 1 to 17. So any integer is a multiple of 1 by definition. So it's got to have a factor of 2. It's got to have a factor of 3 if it's divisible by 3. If it's divisible by 4, it needs to be 2 times 2. If it's divisible by 5, it needs to have a factor of 5. If it's divisible by 6, well, this is already divisible by 6 because we've got a 2 and a 3. It needs to be divisible by 7. It needs to be divisible by 8. At the moment, it's not divisible by 8. We need another power. It needs to be divisible by 9. At the moment, it's not. We need another power of 3. Now it needs to be divisible by 10. Well, it kind of already is because it's got a 2 and a 5. Needs to be divisible by 11. It's already divisible by 12 because it's divisible by 4 and by 3. Not divisible by 13, which is a prime. Is divisible by 14 because it's got a 7 and a 2. Is divisible by 15 because it's got a 5 and a 3. Not divisible by 16. We need another power of 2. The last one. And then finally 17. Now, what we can do is we can multiply everything in this equation up by L17 to make h the subject on its own. So you're going to get this. All right. Now, when we go to divide this by 17, well, L17 has 17 as a factor. So when you divide it by 17, it has no remainder. So we can just get rid of that. That is not going to have it. That's not going to contribute any remainder. That's not going to contribute any remainder. That one isn't going to contribute a remainder. This is all because 17 is a prime. The only thing that is going to contribute a remainder is this very last term, which is kind of hinted at in the way that they presented the problem. So let's have a look at what that number will be. So all we have to do is just calculate the remainder when this is divided by 17. Now there's two ways to go about this. One is actually to do the multiplication. You get a very big number, you're going to use a lot of time, chances of going wrong are pretty high. Or what we can do is we can actually write all of them in their sort of remainder from 17 form. And I can go into a bit more detail, I think in another video actually. But so 2 to the power of 4 is 16. I'm just going to try and write these in such a way that they're like quite close to multiples of 17. So if I actually do the 5 times 7, I think I'll do 35. And I'm actually going to split this 3 squared up into, so 3 times 11 is 32. 3 times 13 is 39. You'll see why I've done this. Now, if you multiply, you can now rewrite 16 as 17 minus 1. 35 becomes 34 plus 1. 33 becomes 34 minus 1. And 39 becomes 35 plus 4. Now, when we expand this whole thing out, the only thing we care about are the terms that have no factors, which are 17. which means that we can just focus just on these last numbers. So let's find their product. What's -1? Sorry, I realized I just made a mistake. For those of you that were screaming at me through the screen, that should be 34 plus 5. There we go. Okay, it's fine to make mistakes, you just got to catch them. So we're going to multiply all these together. -1 times 1 times -1 is 1 times 5. The answer is 5. So it's going to be C. Okay, this is a really, really useful technique. Now, I think one of the hardest things actually to do quickly under pressure is to do this thing, okay, where you found the best way to group this up. It's not essential you do this, but it will save some time. So if you want to practice doing something like this, what I suggest you do is you just take some arbitrary list of integers. So let's just do, I don't know, 8 times 9 times 10 times 11 times 12. And then let's say, what's the modulus, what's the remainder when this is divided, I don't know, by let's take a number 15. Okay. And now you have to think about the right way to do this. Okay. There's a few ways you could do this. If you did this way, 8 times 9 is 72. 10 times 11 is 110. And then 12 is just 12. And then you want to find what's the remainder. Well, this remainder is 12. This remainder here from 15 is going to be 5. And this remainder here is going to be 12. And then you would need to multiply these again. But there's a much, much better way to do it. And this is what you can practice just by taking kind of random lists. Keep an eye out. If you multiply the 9 times 10 first, you'll get 90. What is the remainder when 90 is divided by 15? It's 0. So then you don't need to even calculate the rest. You know that this number will be divisible by 15, okay? So it's a really, really good trick to learn. And using these remainders, especially the negative remainders, makes this much, much easier. So remember this, whenever you see remainder problems, you should be thinking about how can I skip the actual calculation and just isolate the remainders. Thank you very much for watching and listening. I hope this was helpful. If you would like some more problems, don't forget to subscribe and of course like and comment, because this really helps me know what everybody likes. Thank you very much. Bye-bye.